his education first at the University of Karlsruhe in Germany, and he got a diploma in industrial engineering. Then he continued to work as a visiting researcher at Tokyo University, and in 1994 he got his doctorate in economics of management of technology in Switzerland from the University of St. Gallen. And for his professional career, he already worked 4 years from 1990 at the University of St. Gallen as a consultant, and from 1995 for 3 years at a company in Heidelberg, AIST as a project manager for new technologies. And then from 1997 for 4 years at the German National Research Center for Information called GNE, for information technology in St. Augustine as a liaison officer for East Asia. And then from 2001 for 12 years he was Fraunhofer Research Institute representative in the office of Japan here in Tokyo. So basically he built up that representation here in Japan. And recently, since July this year, he works at the National Institute for Advanced Industry, Science and Technology here in Japan. His position is Supervisory Innovation Coordinator. So he's German and I'm German, so I get to know him. I visited his house recently, and I learned that 5 years ago he did a very thorough energy efficient renovation of the house, and I saw pictures and heard how this works in detail, and that's not so easy because the workmen you deal with have no experience, no idea exactly what this means, how to do this. And therefore I thought this is not just a theoretical presentation, but today you can really learn how this can work out practical in the Japanese context. And so I encourage him really to talk from his experience.
Thank you very much. So, thank you also Eckhard for the introduction. So, of course, I'm not a specialist for I'm not an architect, but as I told, we had this experience personally in renovating a Japanese house. This will be the second part of the presentation. But I would also like to start with introduction about energy efficiency and also current research and development trends. Concerning my vita, actually, in Germany I have worked for ABB, which is a Swiss-Swedish electrics group, and this company also makes house control system. So already then I had to do this topic, and German National IT Research Center, we had a research group working on room or appliance control via internet protocol. That was 1996, and I introduced them to the industry, and the people were quite shocked because nobody thought at that time about this kind of information technology coming into houses. So when I started here in Japan in 2001, I represented Fraunhofer. Fraunhofer is Germany's biggest organization for applied research for industry, and Fraunhofer has a solar energy institute that has a department of energy efficient buildings, and also Fraunhofer had a building physics institute that is very in-deep researching into such technology. So this is a little bit the background which I also used for our own house. So I hope it can be an interesting presentation. So first is actually introduction. So why are we thinking about low energy houses? And I got here the trends in final energy consumption by sector in Japan. And you can see that industry is quite flat, and transportation also more or less flat, but you see a big increase in the commercial and residential sector, which is actually the buildings, and the number is actually from 1990 to 2012. We have an increase in energy consumption in the building sector by 42% almost. So although Japan tries to keep or even lower energy consumption, we have a big increase in the building sector. So why is this? The reasons are actually quite simple. So you have now a bigger residential floor space. So old Japanese apartments were very small, now they are becoming bigger and bigger. You also have the same in commercial sector. You have now big supermarkets and big shopping centers. So also here the whole floor space increased. Then you use much more air conditioning. So today, like in Europe, people keep the whole apartment warm or cold, whereas in older times in Japan, only the place where you are just living or sitting is heated or cooled. So my mother-in-law, for example, when we go there in the winter, she has this kotatsu, and we are sitting there with a small fan, and then only this small space is heated. But now people have a big apartment and they air condition or they heat the whole space, which, by the way, is also done in Europe. Also extending opening hours, rise in floor space in office buildings, and also office automation, which costs more energy. So 41% is quite a big sector, and 42% is quite a big increase, and the sector or the energy consumption is quite a lot of the total energy consumption. So it makes sense to have energy efficient buildings, and it also needs energy efficient building equipment. So of course you need LED lights, you need more efficient heating or cooling air conditioners, for example, and also the whole topic smart building. I do not want to go into detail about those kind of things, so my topic today will more focus on energy efficient buildings, and this I want to show in the next slide. So what is actually energy efficient house? So basically, if this is, for example, your house, you have passive heat gain, which comes maybe from sunshine, which also comes from the heat outside, which goes through the wall, or sunshine goes through windows, for example. Then you have internal heat sources that can be a radiator or something, but also the people themselves, they emit some heat. And you have electric light and maybe kitchen and so on. So all these components emit some heat, and then you have maybe even some storage, but this is maybe more in the way of energy efficient houses, but the walls can also store some energy. And then you have heat loss. On the heat loss side you have one thing is ventilation. If you open the window or if you have a ventilation system, you need fresh air, so you have to ventilate. And again, here you have the transmissions through the through the walls actually. So if we think of energy efficient house, we have to think about the transmission. So in winter it's, for example, good to have heat coming through the sunlight, but in summer it's not good because it needs air conditioning. So you have to think about the transmission into the house and also the loss through the walls, through the windows, and through ventilation. So if you think of energy efficient house, you have low use of energy, what I said before, through efficient devices. So you need very efficient lighting, or you have to use the daylight as much as possible to avoid switching on the light. So then we have to have efficient heating or cooling equipment. And I think here Japan is really extremely well. So to my knowledge, air conditioners from Japan are among the best. So I think in all this, and also LED lights and so on. So I think in this devices side, Japan is doing very well. Also home energy management systems, etc. But then of course you have to reduce the heat and cold loss through better and also through outside insulation of walls, then better insulated windows and also window frames. So in Germany, for example, now triple glass is standard for new houses, whereas when we renovated in 2009, the Japanese construction company suggested single glass windows in aluminium frames. So this is of course not very efficient. Then also the loss of energy through unwanted ventilation. So you have a lot of wind going through a house, and this also loses a lot of energy. And therefore, what's quite efficient is if you have an artificial ventilation system with heat exchanger for energy efficient houses. So if we look to Germany, the industry developed quite a lot of low energy houses, and the current status, this is from 2010. This was built in Stuttgart as a model house. This is a plus energy house, so this house produces energy by having, of course, photovoltaics around, but also very efficient insulation. And if you have a plus energy house, you can have an electric car and use part of the energy that your house produces for your mobility. So I think this will be the future, that we have houses that produce energy instead of costing energy. So this is a little bit, how can I say, the future vision actually. But of course, from this house to practical houses that you can buy, it's a long way, but you can already buy zero energy houses in Germany. So the R&D trends, and here I would like to shortly introduce what I was doing before. Fraunhofer in Germany has 66 research institutes and altogether 23,000 people, and the budget is 1/3 coming from ministry, from public research project funding, and 1/3 is from industry, so it's direct contract research for companies. And one of the 66 institutes is Fraunhofer Institute for Building Physics, and they are located in Stuttgart, in southwest Germany, and near Munich they have a kind of a big area with all kinds test houses. So small buildings where they can test new wall systems and insulation systems and all these kind of things. So this is quite a big area with many of the small dots being just for tests, and the bigger buildings is actually laboratory building. And they have another one in north of Germany, so they look into many topics, also acoustics, but energy efficiency and building systems is the biggest topic. Also into lighting and also indoor environment and so on and so on. So some new R&D topics are you have the wall can store a lot of energy, but of course the wall has to be quite thick. Concrete wall, for example, to make it thinner and lighter. People now start to use so-called microcapsules that are a little bit like wax. So wax also, when it becomes hotter, suddenly becomes liquid, and in this so-called phase change, they can save quite a lot of energy. So this phase change materials actually, if you see here the temperature and the storage, energy storage, they are a little bit like this. From a certain point on, they make a big step. That's when the phase changes from solid to liquid, and they can save a lot more energy. So with this you can make a very thin and light wall, but still you have a lot of energy storage capacity.
So that's beeswax? It's like beeswax?
Yeah, it's of course more sophisticated, but it's a little bit the same kind of effect. So you have a change from solid to liquid, or almost liquid, and this can save much more energy.
Yeah.
Than
heating and cooling, but not generating.
No.
Yeah.
That's just storing.
Okay.
So another topic coming in the future is vacuum insulation panels. So if you have vacuum, for example, in windows, it's already used. If you have a vacuum inside, then insulation is the best. The problem is, of course, to build something with a vacuum needs mostly very solid structures. So people now start, and I also had some demand and discussion with a Japanese company that is making refrigerators. They were thinking of using this vacuum insulation panels from refrigerators for buildings, and I think it's still a matter of costs, but this might also be very interesting for the future. So Fraunhofer Institute here is, for example, developing a kind of pressure sensor that tests if the vacuum is still existing inside this kind of building, and it can be some passive pressure sensor. Passive means it doesn't need electricity. You have some device you hold to the wall, and you can read if the vacuum is still working or not working. So these are things the research is working on. This is some aerogel. This is basically like a foam where you manage to make this outer surface solid. So you have some bubbles inside, and this is very lightweight and has a very good insulation behavior. So this is used, for example, for light vents, which is lighting in factory buildings, for example. A new trend in Germany is also renewable material, so some kind of glass wool with binders made from renewable raw materials, or this kind of insulation brick which is made from clay and some polystyrol and some concrete inside, so a prefabricated brick. And one thing maybe we have to consider, and I would like to mention, is if you insulate a house, the higher you insulate or the better energy performance you have, the more risk of moisture you get. So this is because you have a lot of humidity through usage. So of course you have humidity through rain coming into the house, humid air coming into the house, but also through usage. So every person generates, I think, 3 liters of humidity per day by taking a shower, by cooking coffee and or tea in Japan. And so you have a lot of humidity and you have to transport this out. And for this actually in high efficiency buildings you need also some automated ventilation system. To simulate actually this behavior of the walls and towards humidity and also heat, the Fraunhofer Institute has developed some software system that where you put in actually your wall. So this is a typical German wall. You have here some plaster, inside plaster. You have this is 17 or 18 centimeter of brick. Then you have 6 centimeter insulation, some mineral fiber, and again you have 10 centimeter of brick outside. And here you see the software actually simulates the temperature. So there are databases for every location, and they can simulate the whole year. And you see here the temperature is maybe only 10, between 10 and 20 degrees, and you can see how much this influences the inside temperature. But more important is actually the humidity. So sometimes here you have a very high water content if it's raining, and the important thing is here behind your wall, it should be not too humid. So usually 80% humidity, you have fungus and such kind of things. So to avoid this humidity, actually very important is a kind of vapor barrier. I explain this because we also see this later in the reforming of our house. So adaptive vapor barrier means that this is a kind of plastic foil where the pores are variable. So in summer, for example, the pores are very big. So if there is some condensed water because of big heat outside, you have condensed water inside the wall or inside the roof insulation, then it can go through these pores to the inside of the room. Whereas in winter, for example, in winter it's usually more humid inside your building, and then the pores get much smaller and prevent that humidity is going into the wall. So important thing here is really that you have to secure that the wall gets dry. If there is water, you have to prevent water getting in, and if water is inside, you have to see that it gets out. Now I'm working, we introduced already, for AIST. This is the Japanese National Institute for Advanced Industrial Science and Technology. And at AIST we have, as you can see here, also many different locations. Altogether 50 institutes with roughly 8,000 people working. And One of the location is Nagoya. I think should be here, I guess. If I see Japan I think it should be somewhere here. So actually this is the Nagoya Research Institute of AIST, and they have a special field test facility for construction materials. So also here construction material is a big topic, and also here one development is here it's called humidity control material, so some kind of clay material that has very high water absorption, and this can be used in water retentive bricks, for example, that can absorb some humidity when it's getting hot and cooling down the environment, but also used for the walls. Then some wood forming technology, so you have wooden window frames, and also some kind of window which is switchable. So if you switch it to some kind of mirror state, then it keeps out the sunlight, which you can see here. Here this is transparent, so you can see through, and here it's like a mirror, so you see a person like in a mirror, and this can actually reduce 30% of cooling compared to transparent glass. And this is the facility. I also visited this some time ago, so these windows are tested here with sensor systems inside, and also this water retentive tiles for roofs, and also for buildings are tested outside. So I think now we come to the maybe interesting part, renovation of our private house. So in 2009 actually, actually much before, we were looking for some place to buy in Tokyo, because the rent is very high, so we thought it's better to buy and live in our own place, but it's of course very expensive. So what we have found is actually some leased property which belongs to a temple, and we have leased this for 20 years. And we looked at many such things, but usually the house, after being 20 or more than 20 years old, is almost very rotten. And here we found a property where the house itself, that is the look 2009, the house itself was still pretty well. And here you can see the picture how it looks like now. So I took the picture just last week, and you can see that it's basically a little bit the same, but we changed quite a lot, and I would like to explain that now. So when we started, we really took apart the whole thing, and you can see here even the side walls we took off. So we stripped it down to the wooden frame, and then we rebuilt the whole house. So here is new outside wood panels, and these are some pictures from the inside now. We have used Canadian windows. I told that our construction company actually suggested, that's maybe better. Oh, fantastic. So the construction company suggested Japanese windows, and we found a construction company that was open to just exchange positions in their offer by things that we bought by ourselves. So my wife got these Canadian windows. It's double glass windows with some kind of heat reflection shielding. It's not the standard of high efficiency German windows, but they are, I think, very okay and very good, and they were cheaper than actually the Japanese windows. And you see here we have a lot of them, and here's a picture how they are built into the house. And I talked about this membrane which prevents humidity going into the wall. And here you see already when the window was built, we have this membrane sheet already surrounding the window, which was not easy to do. So we had some consulting from a German architect who has done this before. Then insulation, so we have used this, I think it's a French company, Saint-Gobain insulation material. And also concerning this, I can tell a story that the construction company actually wanted to use ready packed insulation material. But first of all, for 10 centimeter wall, they suggested 5 centimeter insulation, because they said Japan is not, Tokyo is not so cold in the winter. But I said it's very hot in summer, and insulation also prevents the heat coming in, as well as maybe the cold temperature coming in the winter. So the second was, there is a very weird Japanese standard that this insulation material, which is basically mineral fibers, which are not good if you inhale them. So there was a regulation that they are sealed in plastic, and if you use this and you get condensed water inside, then all the insulation is gone, and this is actually a catastrophe. So we also had a good advice from a German architect who said, don't use this. The construction company wanted to use it, but we insisted, no, we use this big sheets, and they have to cut and process by themselves. So you also see here the blocks. So in the wall, in the ceiling, we have actually 20 centimeter, and in the walls we have 10 centimeter. And here you see this intello, you see is this membrane, which lets water out of the wall, but prevents to have humidity going into the wall. So this is also very important, and this actually drove our construction company crazy, because they are not used to processing such kind of things. So you have to glue this with a special tape, and actually you have to check if it's really nicely airtight, because this foil also has a second effect, it's airtight. So you actually make your house airtight, and you prevent this unwanted ventilation. The next part is outside insulation, and I have 1 hour presentation about outside insulation. I don't want to go into too much detail, but the problem is usually you have your wall with 10 centimeters, and we put another 3 centimeter outside. It's this polystyrol we put around the whole house, and this actually shifts your point where maybe the cold air in summer inside the house and the hot air outside where they meet. So you have more, actually more space where this temperature difference can level out, just to say in a simple word. So this is actually proved also as a very important thing. So we put a lot of effort here. So this is the outside insulation, and then you have this siding, which actually covers the whole house. And concerning heating and cooling, we have decided to have floor heating in the first floor, which is this system. So the whole first floor is floor heating, and you can see here, this is actually our living room. It's about 2 stories, so it's a very high space here. So here's actually, this is the first floor basically. So because this is open, the heat actually goes up and goes into the second floor. So in winter, we just heat the whole house with this floor heating. And we don't need any air conditioner. So this last winter, we never used any air conditioner. And it was still nicely warm even in the second floor, where we have the bedrooms and our daughter's room. And in winter and in summer, we have 1 air conditioner hanging here, and this is also enough for the whole house. So 1 air conditioner is fine to cool down the whole house. Yeah, I was talking before, these are some other pictures of this membrane. This is the roof, and this is my daughter's room here. And you see here through this foil, you see this red insulation material, and on top is this membrane, and it's sealed with this blue tape, with this such a terrible gluing tape. It's really some effort to process this. And on top of this, we have this plasterboard, which is I think standard here in Japan. And on top of this plasterboard, we have then wallpaper. And you can see here, this is my daughter. She was much smaller at that time. We even painted it by ourselves. And here we have wallpaper. Here in Japan, that's also what the construction company suggested. You have vinyl wallpaper, and vinyl is not, it's humidity tight, and then you have the same effect. Humidity cannot get out of the wall. So also here we had good advice of the German architect to use, this is also German wallpaper, and even the glue. He said don't use Japanese glue because it's a chemical glue. We had, and he brought glue from Germany, which is a natural thing, which you just mix with water and then you glue the wallpaper, because again, then the glue is also not, it's like a kind of a humidity barrier, and then you have the same problem if humidity is inside the wall, it doesn't get out. So we even had to look at such small details. And you also said that you had some, blower tests. So yeah, what we did then is actually such a blower test where you seal all openings in your house, and this machine makes some under pressure of actually 50 Pascal, and then you check with some sensor systems if this under pressure is held by the house or not. So basically if the house is open somewhere and air comes in, or if it keeps this 50 Pascal under pressure. And according to German regulation, this is a kind of coefficient. We have a coefficient of 2, which means that with 50 Pascal under pressure, the whole air volume of the house would exchange twice per hour. It sounds quite a lot, but it's actually criterion for a low energy house in Germany. It has to be 3 or better. If you have this highly insulated passive houses, which are really highly insulated, then the value is 0.5. So even much better, but For a renovated house, I think with a value of 2 we are very good. And so maybe one word concerning this test. Normally you actually do this blower test when you have this construction state to check if maybe this is nicely glued or if somewhere some air comes through. The problem in Japan is the way of building the house is different. In Germany you have first the basic construction of the house, and then the next people come and put the wallpaper, and then people come and do all the electrical installation and so on. So it's step after step. But here in Japan, in the top, people were already putting wallpaper, and in the first floor, still the floor was open, and they did some water pipe installation system. So we could not check in this state if the house is airtight. So we could not check if there are some problems with actually processing this kind of membrane system. So this was, we found out actually too late when we actually said, we have to do a blower test, but it was not possible because they already wanted to process with the wallpaper. So it was not possible without having to change the whole construction and causing additional costs. So what we did is basically, when the house was basically ready, like here, everything, wallpaper was on, everything was done. Then we did the blower test, so we only have the final result, but we could not improve any possible problems. This is actually the owner of the construction company. And what happened is air came blowing out of the light switch. And the problem concerning our house was that one day when I came, the unit bath was built in, but there was no insulation between the unit bath and the outside wall. So we were quite shocked, and they told us, it's always done like that in Japan. So, I explained to him, we talked about a closed building envelope, which is airtight, and then it can't be a 4 square meter hole is inside because of this unit bath. So this was the typical problems we had, and so I told him, you stand here and put your hand here and I take a picture. And then he said, okay, he admits it was the unit bath. And he was quite shocked because he said, no, he understands actually what the whole construction is, what airtightness means, and why we had not everything perfect, basically. So, yeah, another thing is our ventilation system we have installed. So, I think in Japan you have the problem that people sometimes do not want to open the windows. So my mother-in-law, for example, she's in winter, she says, don't open the window, it's cold outside. And you have the water running down the window because this condensed water is collecting because it's too humid inside, because you do not exchange the air. So
mainly because of breathing.
Yeah, breathing, bathing,
Yeah.
cooking, all this, and sweating. Every person emits some humidity, so you have to transport this out of the house by ventilation actually. And if you do not want to do this regularly, or usually nobody does it regularly, so actually it's good to have a ventilation system. And this machine actually has a heat exchanger here inside, so the used air is going through here, I don't know if this direction or this direction, and the fresh air is coming in here, and it's a cross heat exchanger, so the energy is exchanged. So in summer, the fresh air is cooled down in this machine by means of the used air, which is air conditioned, and in winter it's the same vice versa. So this actually saves a lot of energy, and finally also you have 24 hours ventilation, you always have fresh air. So yeah, this was, I think, already the last picture, and now I have already conclusions. It's difficult to say, but our experience showed that it's not such an easy step, but on the other hand, it was not very sophisticated or expensive things that we used. Basically, we have normal insulation material that you can buy in Japan. We used double glass windows, which we also bought in Japan instead of single glass windows. We had this membrane that cost a little bit, but and then the outside insulation. So altogether, it was not much more expensive, but we have a house which is very comfortable and which does not use so much energy. So even when we air condition a lot in summer or so, maybe we have, in the past we had 20,000 yen electricity bill, and my wife's friends, they have a smaller house and they have something like 40,000-50,000 yen electricity bill. So we saw already it's helping a lot. And what I didn't show here in the pictures now, we also have now a solar system installed, and by that actually we save quite a lot of energy, and I haven't done any sophisticated calculation of this house, but I think it's at least a small step what could be done. And yeah, in that sense, I would like to stop here and maybe have some more discussion. Of course, similar things are also valid for office buildings where you can save a lot, but I don't want to go into too much detail. Yeah, thank you very much.